Hey everybody, sorry I am not here today, but we will continue with our next unit, which is over logarithms. If you want to look in your book, it starts on page 273. We're going to be able to write them, evaluate them, and we're going to graph them. Today's main focus is going to be convert back and forth between logs and exponentials, and we're going to start graphing them as well. Okay. We're going to look at a specific log called a common log, which we'll get into a little bit later. All right, so first off, I need to know, well, what is a logarithm? All right. Well, we've been dealing with some exponentials lately, right? So let's say I had an exponential of 2 raised to the power of x, and I asked you to solve for x, okay? Well, right now you can't do that because you don't know what it's being raised to. In the past, if I gave you an x squared and said solve for x, what would you do? Well, you would take the square root, right? So that way the radical and the power cancel each other out, and we have x left over. Well, up here with my 2 raised to the x, I don't know what the root is. This is unknown, therefore I don't know what root to take. So the inverse is going to be a logarithm, okay? Like the inverse of addition is subtraction. The inverse of multiplication is division, okay? Here, the inverse of exponentials is a logarithm. So that is the definition of a logarithm, okay? It is the inverse of an exponential function. Okay, that's how we're going to use it. The first way we're going to look at it is we're going to convert back and forth. So any exponential I can write as a logarithm and back and forth, okay? As long as the value of b is bigger than 0, and we usually don't let b equal to 1, okay? So on the left-hand side, you have base b being raised to the power of x is equal to a value of a, okay? That can be converted to, and this is how you read it, to log base b of a is equal to 6, all right? So you see that the exponent from the exponential value, that x, is what your log is set equal to. So your log is the exponent, all right? That's how we're gonna solve. There's a couple of tricks besides memorizing this back and forth, okay? Okay, we can use the L or the E to help us convert back and forth. So what I've given you right now is an exponential function, 9 squared equals 81. That's something that we know. I'm going to make this into a log, all right? So I'm going to change this into a log. So I'm going to draw a big ol' L. So log base 9, that's where I cross first, of 81 is going to equal 2. Now see how I drew a big L? So I did that, so I made a big ol' L. So log base 9 of 81 equals 2, okay? I can do this same trick looking at a log going back to an exponent. I'm gonna make a big E. So right now I have log base E of 512, okay, is going to be equal to 3. Well, I need to make that into an exponential. So I'm going to take my E. We're going to start with the 8, start with my base, okay? We always start with the base. The base is always first. So I'm going to start with my 8, raise it to the 3, and then it is equal to 512. So I just did the base of 8, exponent of 3 is equal to 512. I did that by creating a big lowercase e, right? Remember, your base is always first. Always, always, always. All right, so hopefully these are nice little tricks to help you out. Next slide, we have a couple examples going back and forth. I'm gonna do a couple of them first, and then I'll let you practice with the next slide. So these first two are equivalent to each other. I have 3 cubed equals 27. And log base 3 of 27 equals 3. That is the same. I'm going to come to the next one. 5 raised to the negative 1 is equal to 0.2. So I have exponential. I want the log, so I'm going to make the L. All right? So we need logs. This is what I need here. I need a base 5, right, of 0.2 is going to be equal to -1. See how that happened? I made my L. All right, my next one, I have a log, I need an exponential. It means I need a base raised to an exponent. So I start with my base of 4, right? Raise it to the 2, and that is going to be equal to the number 16. All right, my last one. I have an exponential, so I want a log out of it. I'm going to start with my base of 8. It's going to be of 1 and set equal to 0. All right. That's how we convert back and forth. Number 2 wants you to explain why the logarithm of 1 with the base of b is always 0. Well, think about it. If the log is 1, that means it's always going to be 0, because that means that the exponent had to be 0 to be equal to 1 every time. Okay, if my exponential was equal to 1, meaning I'm doing a log of 1, then the exponent had to be 0 itself every single time. Okay. Here's a practice page. I want you to push pause, try it on your own, and then press play and see if you got your answers right. Okay, so go ahead and push pause. Remember, we're going from exponential to logs here, so you want to make the L to help you convert. Okay, so I hope you did them, and now you're checking your answers. Each time we're going from exponential to log, so I had to create the L. Notice also every single time, guys, that your base always came first. Always. So the base to my exponent here is 10. The base of my log is 10. The base of my exponent is 6. The base of my log is 6, okay? These will always come first. Always, always, always. Your base is always first, okay? I have a table for you on the next slide where you're going to go the other way. So now you have a log. I want you to change it to exponent. So here you're going to use your E. Remember, your base is always first. All right, push pause, come back and check your answers. All right, welcome back. You're checking your answers. So remember, our base always came first. So here I have log base 9. So that means 9 is the base of my exponent on the other side. Make sure your math makes sense, guys. 9 to the power of 1 is 9. You know that. Okay? If you wrote 9 to the power of 9 equals 1, you should know that that's not correct. So make sure your math is making sense. Okay? You'll see at the bottom, like we said before on my last slide, if the log is equal to 0, that means that the exponent was 0 and it's always equal to 1 every single time. All right? Feel good about it? There are some special cases maybe you noticed along the way. Like on the last slide, the very top one, we had log base 9 of 9. So here, our two values were the same number. It was equal to 1. That'll happen every single time. Okay, so the last slide, we had log base 9 of 9 equal to 1. And we saw when we rewrote that, we got 9 to the power of 1 equals 9, which is always true. Okay, then the very last one of the column, we saw that no matter what the base is, if it is log of 1, it will always be 0. Always, always, always. Because that means the exponent was 0, which is always equal to 1. Those two will always go together. Okay? Always and forever. No matter what the base is. That base could be 100 million. I don't care. If it is of 1, it will always be equal to 0. Okay? Well, there's some special properties to keep in mind. This video is going to end. I want you to go to the next video, which is all about graphing logarithms. Okay? So this video is done. This was about converting back and forth and some special properties about logs. Next video will be about graphing the logarithms.